So again, think of this as balancing with models. You need to recognize what are compounds versus what are individual atoms. So, so HCl, that is a compound. The H is bonded to the Cl. So, I'm going to have an atom represented with an H. There's my hydrogen atom. Here's my Cl atom. There's my HCl. It's bonded together. So H is touching, connected to Cl. I'm going to add to it Na. And then what you don't know is that your oxygen is connected to your hydrogen, like that. But notice they're all bonded together because they're all a single compound. NaOH, NaOH. Oxygen has to be touching the H, it has to be touching the Na.
It's like if they're all together, they always should be touching at all times.
If they are a compound, they should be touching.
What about the products? Or same thing?
Products, look, NaCl is touching, right?
Yes, you do it together.
So I put a circle with Na, circle of Cl, it's together.
For the OH, once you split them, would it matter?
IO.
What do you mean split them?
Switch, like the
Okay, so technically I wouldn't count off for that because you don't know what OH is yet.
And what
But
if you put them like this? Like if this is
again, as long as they're touching, you are recognizing what I'm trying to get you to recognize. They are a compound together. I have not gone over bonding with you guys. We will not go over it until a little bit later on in the year, but once we go over bonding, then I would expect you to draw something similar to what you're seeing here. So if you're looking at water, again, I wouldn't expect you to necessarily have this, but your oxygen, your two hydrogens are connected to your oxygen. Your two hydrogens are not connected to each other, but I wouldn't expect you to know that. All I'm looking for is that you recognize water is made up of two hydrogens and one oxygen, all bonded together. Questions on number 1? So for number 2, we add in the coefficients. Our ratio for number 1 was 1 to 1 to 1 to 1, so we didn't have to worry about those. But what happens when you have two different compounds? So here, Na, notice it's not Na subscript 2. Na subscript 2 is different from having a coefficient of 2. So if we have a coefficient of 2, that means we just have two Na atoms like that. They're not connected. They're not a compound. Versus Cl2, those two chlorines are connected. So plus Cl connected to Cl. Now, I have NaCl being produced, so Na connected to Cl, and how many of these NaCls do I have?
2.
So I need to draw 2 of these compounds. Again, law of conservation of mass tells me I cannot create nor destroy matter. So I end with the same amount of atoms, same type of atoms that I start with. They're just rearranged into different compounds. All right, number 3. 2 aluminums plus, now here I have copper connected to 2 chlorines. And how many of these do I have? I have 3 of them. So, 1, 2, 3 of these compounds.
Cu together? Be Cu, Cu, Cu.
Yeah, but not together. the coefficient tells me I have 3 separate coppers. If they were together, it would be a subscript. But because it is a coefficient of 3, I want you to recognize I have 3 individual coppers. Now, if I look at AlCl3, I have 2 of those. That means I have 2 of the compounds of Al connected to 3 chlorines. There's 1. There's 2. That is how you would model each of those reactions. Remember, I gave you the opposite. On the test, I gave you this right here and asked you to write out the reaction equation. Or I gave you this right here and asked you to write out the reaction equation. So I wanted to see if you knew what each subscript meant versus what each coefficient meant. Many of you did not or were not able to differentiate between the subscripts and the coefficients, and that's where you went wrong on your test.